Hey guys, it's Mrs. Applegarth, and I am happy to walk you guys through section 4.4, using corresponding parts of congruent triangles. We talked a lot about corresponding angles, and corresponding angles, if you remember, are angles that are in the same position. So they're both to the right, they're both above the parallel lines, and they're buddies together. So we're going to extend that idea to congruent triangles. So we're going to look at this little kite figure, and so the first item that we're given is that angle 1 is congruent to angle 2. So let's go ahead and put those congruent marks on our triangles. And then angle 3 is congruent to angle 4. So we're going to put a double, I call these the double rainbows. So we put our congruent marks. All right, so our hint here that we're given is that we're going to prove triangle ABC is congruent to triangle ADC. So I always like to redraw. It takes barely any effort to redraw the triangles not super close together. So I'm going to take this hint. I'm going to redraw triangle ABC and ADC, and I put our congruent angles on there. And so our first item that usually under most circumstances, every first statement starts with the given. So I'm going to take angle 1 congruent to angle 2, and angle 3 congruent to angle 4, and I'm going to put that in our first statement. And the reason I can say that is because that is given to us. Now we always want to look for overlapping. In this triangle, AC is overlapping. And when we get an item, AC is congruent to AC all day, every day. It's the same side. So that is the reflexive property when an item is congruent to itself. All right, so I'm going to put that mark on my triangle. So now I have an angle here, a side here, and an angle here. So I can say that these two triangles, triangle ABC, this bottom one here, is congruent to ADC by the angle side angle property. So this is where we're going to use corresponding parts of congruent triangles. So we get to say when a triangle is claimed to be congruent, so the okay, so we just took and proved that these two triangles, the ABC and the ADC, are congruent by angle side angle. So if we prove that these two triangles are congruent, then all their parts are also congruent. So we can put congruent marks here. We can put them here. Move my arrow out of the way. And we can claim that this angle here, D, is congruent to angle B. So once we declare the triangles congruent, all their parts are congruent. So let's take a peek at what we actually want to prove. We want to prove that BCE, this is this triangle here, is congruent to DCE, this triangle right here. So again, I am redrawing that triangle. I have on my triangle the items that are congruent. And I do have, from the given, I have angle 1 and angle 2 being congruent. So let's take a look at side CD, which is right here. Congruent, that's the side right here, is congruent to side CB. And we can say that those two sides are congruent because corresponding parts of congruent triangles are congruent. That's what CPCTC means. It means corresponding parts, congruent triangles are congruent. So we can say that that side is, these two sides are congruent. Okay, the next item that we want to look at is we want to look again for anything reflexive. So we look here, we see that CE is our overlapping side. So we can say that CE is congruent to CE by the reflexive property. So let's put that mark. Let's do it in black. So those are these two triangles. Okay, so now let's go ahead and go around our triangle. We have, if we start at this CD, we have a side, an angle, and a side that are congruent. So we can say that, and this is our, anytime you are proving something, it should always go at the very end. It's actually, we're trying to prove triangle BCE is congruent to triangle DCE, and that's by side, angle, side. So that's how we use corresponding parts of congruent triangles. I like this next one because it does a really good job of showing vertical angles. And that's a spoiler alert. So let's look at what information we're given. We are given that angle B is congruent to angle D. Let's go ahead and mark that on our diagram. And we're also given that C bisects AE. So if C bisects AE, then the definition of a segment bisector means that it creates two congruent segments. So if C is right in the middle, it's going to make an AC congruent to EC, and that is called the definition of a segment bisector. All right. The next item that we're going to look at is angle 1 and angle 2. I love these little bow ties. Anytime you have this little bow tie shape, please know that you're going to be striving for vertical angles. So the reason we can say angle 1 is congruent to angle 2 is because they are vertical angles. They're right across from each other. They make, you could think of it like this too. If it makes an X between what letter is over there in the alphabet, kind of a round X. Oh yeah, V for vertical angles. My pointer. So here's our two angles. Okay, now we can say that triangle ABC is congruent to triangle EDC. ABC congruent to EDC by, and let's we'll put this is angle, We go next, we have an angle. And lastly, we have a side. Angle, angle, side. So you make sure you're going around the one that doesn't have a gap. So if we went the other way with it, so if we went angle and then this way, we're kind of missing this part here, and we don't get the other angle either. So we have to go around to the left. So we go angle, angle, side. So we look here in our definition. It's actually not written down there. So that's by angle, angle, side. All right, and then last but not least, we can say that angle A is congruent to angle E because corresponding parts of congruent triangles are congruent. If we've already declared the triangles congruent, like in here, then we know all their corresponding parts are also congruent. All right, thanks for watching.